So carbon is an extraordinarily important element. The mass of carbon-12 is used as the standard for measuring the weight of all the other atoms on the periodic table.
So carbon, it's around us everywhere. We're all carbon. There's lots of carbon in us, in all the hydrocarbons within our body, lots of the structures inside us, and many of the materials that we use every day. In fact, a majority of us use carbon in the form of fuels every day to get to work or to go home.
It's also, of course, the basis of all the life, the so-called organic compounds which make up you and me, but also the element carbon itself is quite exciting. And it exists in a number of forms. For example, here this is so-called amorphous carbon. That's carbon that doesn't have any particular form. This is an element such as you might use in a gas mask. The gas goes in here, the poisonous material is absorbed, and clean air comes through here. So you can breathe in and out through that.
So carbon's an extremely common element, but it comes in a number of different allotropes, so different forms. And this one here, this is actually some charcoal, which is just simple carbons, very similar in very in fashion to graphite.
It's also, I think that carbon is the element which has perhaps been the subject of one of the most exciting developments in the whole time I've been in The Chemist, when Harry Kroto and his colleagues discovered so-called Buckminster fullerene, this molecule C60 that has the shape of a football, which nobody had imagined would exist and be stable, and now chemists all over the world are using it. And not only can you get carbon arranged as footballs, they now realize that you can arrange them as arranged as long tubes, so-called nanotubes, and you can even put the C60, the football, inside the nanotube. And one of my young colleagues here in Nottingham is making what are called nano pea pods, where you put these balls of C60 all the way along a nanotube, just like the peas in a pod.
So carbon comes as graphite, as diamond, and also as buckyballs or fullerenes. So the carbon here, which is a bit like the graphite, is very amorphous, and it's very free flowing. So we're going to pour a little bit of the carbon out onto the paper so that you can see. So you can see it's a very light powder, very dark powder, and you can see that it's a very nice, easily maneuverable and easily workable material. Very beautiful material. Often used as a lubricant in the form of graphite, which is very soft in one dimension. But also the other allotrope of carbon, which is diamond, is extremely hard. One of the hardest materials known to us. Very unreactive, and perhaps it's why we give it to our loved ones as engagement rings.